morning, students. Yes, chapter 4, motion in a plane. We have discussed about addition, subtraction, multiplication, dot products, cross product. Okay. Yes. Now we will see topic which you have learned in chapter number 3 about displacement, velocity, and acceleration. Okay. But how to write displacement, velocity, and acceleration in vector form? That we will discuss today. Yes, title is position vector and displacement. First of all, we will understand how to write any position vector. See, position vector. Position vector. For example, I have x-axis and y-axis. Okay, it is origin. It is origin. X-axis, y-axis, it is origin. One particle is here at this point. One particle here is at this point. Then how to find its position vector? Draw a vector from origin to that point. It is called position vector R. It is called position vector R. Okay. Now see here. This position vector, if I draw perpendicular on x-axis, it is x component of position vector. If I draw perpendicular on y-axis, it is y component of position vector. Clear about this? Okay. So here position vector, position vector of particle P, R is equal to, how to write this R is equal to? Yes, we know how to write in terms of components. It is xi plus yj. It is xi plus yj. Clear about this? So yes, remember, if we have a particle P, xy coordinate system, origin, yes, to define position, we have to select one reference point. And what is reference point? Origin O as reference point. Origin O as reference point. So you have to find each and every position with respect to this origin. So yes, here we have one particle P. Its position vector is R. How to write position vector R? X, it is its x component, means in x-axis direction. Yj is y component. So how to write? R is equal to, it is xi plus yj. See, right now we will discuss particle in two dimension, means in xy plane. But if you are given any particle, in three dimension, then how to write its position vector? Then its position vector is R is equal to, you can write xi plus yj and plus here it is zk. Clear about this? So yes, you have to remember this thing. Position vector of particle P, R is equal to this xi plus yj, where it is x coordinate and it is y coordinate. Now we will see what is displacement. See about displacement. Okay. For displacement, we will take one condition. Okay. Let it is x-axis, it is y-axis, it is origin, and we are taking motion of a particle. Let one particle is moving on a path like this. One particle is moving on a path like this in this direction. Okay, one particle is moving on this path. Suppose at time t, particle is here at point P. Clear about this? Then what is its position vector? Its position vector I will denote by R1. Okay, for example, path of particle is as shown in figure. Path of particle is as shown in figure. Okay, let at time t, particle is at P. Particle is at P. So therefore, its position vector. Okay, I am writing as R1 is equal to, how to write R1? Okay, yes, we know R is equal to xi plus yj, x coordinate and y coordinate. So yes, here if it is R1, then it is its x coordinate, then it is its y coordinate. So how to write R1 is equal to, I am writing x1 I caret plus y1 I caret, y1 j caret. Clear about this? Okay, yes, it is position vector R1. It is its x component, it is its y component, x1 I caret plus y2 j caret. Now we are seeing particle is moving after some time, okay, after some time, that it is time t1, after some time t2, particle is here at point p dash. Okay, so yes, let at time t2, particle is at p dash. So its position vector is See, first of all we will draw its position vector. From this origin to point p dash, you have to draw one vector, means one arrow. Yes, it is vector R2. Now how to take its component? Yes, you know, from this point draw perpendicular on x-axis, from this point draw perpendicular on y-axis, then you will get R2 is equal to, it is x2 I caret plus y2 j caret. Clear about this? Initially particle is at point P at time t1, then its position vector, it is moving at some time t2. Now it is at point P dash, then its position vector R2 is equal to x2i plus y2j. Now we know that what is displacement? Displacement means change in position, means final position minus initial position. Then how to find displacement? See students, displacement in time delta t is equal to t2 minus t1. Displacement in time delta t t2 minus t1. How to find? Displacement is equal to change in position. Displacement means change in position. Okay, change in position. What is its equation? Final position minus initial position. Yes, very good. It is final position minus initial position. Now how to write? See how to write. What is final position? At time t2. At p dash means R2. What is initial position? It is R1. Clear about this? R1 is initial position and R2 is final position. So now here we have to write is equal to R2 minus R1. Clear about this? See how to write. Okay. Now displacement is equal to final position minus initial position. How to write, students? See, displacement means delta R is equal to, it is R2 minus R1, final position minus initial position. Clear about this? Now what is R2? Yes, here it is. R2 means it is x2 I caret plus y2 j caret minus what is R1? x1 I caret plus y1 j caret, but between there is negative sign. So yes, it is minus x1 I caret minus y1 j caret. Clear about this? Okay, now we will make a group of x components. x2i minus x1i. So I can write this as x2 minus x1i caret. Okay, similarly plus y2j minus y1j means y2 minus y1j caret. Clear about this? So is equal to, I can write delta xi plus delta yj. It is displacement delta r. Okay, where delta x is equal to x2 minus x1. Delta y is equal to y2 minus y1. Clear about this? Okay, so yes, it is how to find displacement. It is how to find displacement. Okay, see, if position vector having x and y components, displacement, it may also have x and y components. Clear about this? So yes, what is position vector? What is displacement? Now next point, we will see what is velocity. What is velocity? Yes, first of all, we will see what is average velocity. What is average velocity? Yes, you know equation of average velocity. Average velocity means displacement upon time. Average velocity means displacement upon time. See here, it is displacement delta r. But what is direction of displacement? See here it is. Initially vector is in this direction. Then at time t2, particle is at point p dash, then its position changes like this. Yes or no? See, my hand is moving in which direction? Initially it is position, then position is changed in this direction. Initially it is position, then position is changed in this direction. So how to represent this displacement vector? Yes, it is displacement vector delta r. It is displacement vector delta r. Clear about this? Okay, so remember, r1 position vector, r2 position vector, and delta r is displacement. Delta r is displacement, and displacement is in this direction. Displacement is in this direction. Clear about this? Okay, so yes, now we will define average velocity. Yes, what is the equation of average velocity? Average velocity is equal to displacement upon time. Displacement upon time. So how to denote this? See, average velocity is equal to displacement. What is displacement? It is delta r upon delta t. Clear about this? Delta r. What is delta r? Here it is delta xi caret plus delta yj caret divided by delta t. So yes, I can also write this equation as v is equal to delta x upon delta t I caret plus delta y upon delta t j caret. Clear about this? Now what is meaning of delta x upon delta t? Change in x coordinate with time. Change in x coordinate with time. So it will give x component of velocity. Yes students, delta x upon delta t means change in x coordinate. So it will give average velocity's x component. So how to write this? Average velocity v is equal to average velocity in x direction I caret plus similarly delta y upon delta t means y component of average velocity. So here I can write it as vyj caret. Vyj caret. Clear about this? So yes, v average velocity is equal to vxi plus vyj caret. Any doubt? Okay, yes, average velocity. See, average velocity is equal to displacement upon time. So direction of average velocity, direction of average velocity is in direction of displacement, okay, is in direction of displacement. So see here, it is average velocity in this direction, displacement it is this direction. See, yes, we know from average value, first limitation, okay, we cannot find velocity at any instant. We know about this, okay, from chapter number 3. Second point, see, here it is displacement vector. a straight line connecting initial and final position. But what is actual path of particle? It is actual path of particle. Is this displacement vector coinciding with this actual path? No. So what is meaning of this? This delta r displacement does not give idea about its actual path. Does not give idea about its actual path. Clear about this? So yes, second is it does not give its actual path. Its actual path. Then how to find? How to find velocity at any instant? How we will get actual path? When we take time delta t tends to 0. Yes, we have proved this concept in chapter number 3. Okay, when we take time interval very small, delta t tends to 0, we know that average value is converted in instantaneous value. Average value is converted in instantaneous value. So yes, here it is average velocity, its equation, its direction, its limitation. Now we will see instantaneous velocity. Okay. Now, if we decrease time interval, see, initially at time t1, particle is at point P. Then at time t2, it is at point P dash. Okay. Now, if I take small time interval, okay, t1, t2, less than this. Okay. Then obviously, if initial position is at point P at time t1, if I am taking time interval small, after some time particle will be like here at point P double dash. Clear about this? Yes or no? Yes. So see, in this situation, what is displacement vector? In this situation, displacement vector is like this. See here, it is initial position, it is final position. So in this situation, it is displacement vector. Clear about this? Okay. Again, if I am taking smaller time interval, okay, then yes, its final position will be let at this point. Suppose it is P triple dash. Okay, then what is displacement? Yes, it is initial position, it is final position. So yes, here it is displacement vector. Yes or no? Yes, here it is. If I am taking time interval small, again, if I am decreasing time interval, and let a point is here, it is P triple 4 dash. Okay, then yes, it is initial position, it is final position. Then yes, if you draw a displacement vector, it will be in this direction. And see, this displacement vector is along its path. And yes, it is nothing but if these 2 points, if I am taking time interval very small, then yes, final position will be here and displacement will be in this direction, such that this vector is in the direction of tangent to that point. Clear about this? So yes, from this we can prove, okay, if I am taking delta t, that is time interval very small. Initially it is time interval, so displacement. If I have decreased time, then it is displacement. Decreased time, it is displacement. Decreased time, it is. Clear about this? So yes, if we take delta t tends to 0, that is time interval very small, we can say average velocity becomes instantaneous velocity. Okay, and what is direction of instantaneous velocity? Yes, direction of instantaneous velocity is in direction of displacement. And see, now displacement is in this direction. It is in direction of tangent. So yes, you have to remember direction of velocity. Yes, I can write instantaneous velocity as only velocity. Direction of velocity is in direction of tangent drawn at that point on its path. So yes, this point you have to remember. Okay, direction of velocity is in direction of tangent drawn at that point on its path. Remember? Okay, direction of velocity is in direction of tangent drawn at that point on its path. Clear about this? Okay, so yes, our two problems solved. First, average value becomes instantaneous value, and second, see, now this arrow is in direction of actual path. So yes, we can also find its actual. Clear about this? Okay. Now, how to find instantaneous velocity? See, instantaneous velocity at time t. V is equal to, it is limit delta t tends to 0, delta r upon delta t. How to write this? See, V is equal to, vector V is equal to, here it is limit delta t tends to 0, delta x upon delta t I caret, plus limit delta t tends to 0, delta y upon delta t j caret. Because yes, students, we know that delta r is equal to delta x I plus delta y j. So yes, I can write this term as this. Okay, now if you know chapter 3, limit delta t tends to 0, delta x upon delta t, it is called nothing but dx upon dt. If you remember, it is called dx upon dt. Then how to write this? See, V is equal to, it is dx upon dt I caret, plus similarly limit delta t tends to 0, delta y upon delta t means it is y component, dy upon dt. Here it is j caret. Okay, now what is this term? See, it is dx upon dt, change in x coordinate upon time, and it is change in y coordinate upon time. Then how to write this? I can write this as V is equal to Vxi plus Vyj, where what is Vx? Vx is equal to dx upon dt, derivation of x component with respect to time. What is Vy? Derivative of y with respect to time. Okay, so yes, here it is equation of velocity. V is equal to Vxi plus Vyj. In short, we can write each and every quantity in terms of components. R is equal to xi plus yj in terms of components. Displacement delta R is equal to delta xi plus delta yj in terms of components. Velocity is equal to Vxi plus Vyj in terms of components. Yes or no? Yes, it is. Okay, so yes, it is about velocity. V is equal to Vxi plus Vyj. Now you know that how to find its magnitude. Okay, magnitude of velocity. V is equal to under root, it is Vx square plus Vy square. Yes, you know its equation. Hello, it is similar to, remember, A is equal to under root Ax square plus Ay square. Now it is for velocity, then we have to replace symbol by V. V is equal to under root Vx square plus Vy square. How to find direction of velocity? Okay, how to find direction of velocity. So direction of velocity, theta is equal to, we can write tan inverse Vy upon Vx. Yes, you know these two equations. Clear about? So yes, here it is all about velocity. You have to remember this point. Okay, what is velocity? Velocity is in direction of tangent drawn at that point on its path. Remember this point. Okay, remember this point. Clear about this? Yes. What is position vector? Clear. What is displacement? Clear. What is average velocity? Clear. What is instantaneous velocity? It is also clear. Now last one is acceleration. Now see, we will see what is acceleration. Here it is. Acceleration. Okay. Yes, first of all we will find what is average acceleration. Okay. For that again I am taking one situation. We are taking one situation. That it is x-axis, it is y-axis, it is origin. Okay. Now I will take one path. I will consider one path. Suppose it is one path. Initially, particle is here at this point, at time t1, at point P. Clear about this? Finally, it is here after some time at time t2. It is here at point P dash. Okay. Now see, we have to understand acceleration. Acceleration means, what is acceleration's formula? Change in velocity upon time. So yes, first of all at this point you have to find what is velocity. And what is velocity? Velocity is in direction of tangent drawn at that point. So yes, see, at point P, what is direction of velocity? At point P, what is direction of velocity? At point P, velocity is in this direction, in direction of tangent. It is v1. Clear about this? Again, it is path of particle. Direction of velocity at any point is in direction of tangent. So particle is at point P. So you have to draw a tangent at this point. It indicates direction of velocity. Clear? Okay. After some time particle is here at this point. So at this point, what is direction of velocity? What is velocity? Yes, it is in direction of velocity, in direction of tangent, in this direction. Clear about this? Clear about this? So yes, initial velocity is v1, final velocity is v2. Final velocity is v2. Again, see, again, it is x coordinate, it is y coordinate. It is path of object, path of particle. Okay. Now at time t1, particle is here at point P. So at any point, how to indicate its direction? We know that at any point, direction of velocity is in direction of tangent drawn at that point. So yes, if I draw tangent at this point like this, it is velocity. It is direction of velocity, that it is v1. Similarly, after some time particle is here. So if at this point I draw tangent, it is direction of velocity v2. So yes, here in this case, v1 is initial velocity and v2 is final velocity. Clear about this? Okay, so how to find average acceleration? How to find average acceleration? See students, similarly you can write, we have v is equal to vxi plus vyj. So how to write this v1? How to write this v1? v1 is equal to v1xi plus vy1j. Yes or no? Similarly for v2. Okay. So initial velocity, final velocity. How to find average acceleration? See. Average acceleration is equal to, average acceleration is equal to change in velocity upon time interval. So yes, how to find average acceleration? Average acceleration A is equal to, here it is delta V upon delta T. Delta V upon delta T. Clear about this? Delta V upon delta T. Yes, how to write delta V? How to write delta V? See, is equal to, I can write this as delta Vxi plus delta Vyj divided by, it is delta. Divided by, it is delta T. And I can also write this as average acceleration A is equal to, it is delta Vx upon delta T I carry plus delta Vy upon delta T j carry. Where what is delta Vx? Change in x component of velocity. Delta Vy means change in y component of velocity. Okay, and now I can write this equation as A is equal to, it is ax I caret plus ay j caret. Clear? So yes, it is equation of average acceleration. And now how to convert in instantaneous acceleration? You know, if delta t tends to 0, then instantaneous acceleration A is equal to limit delta t tends to 0, delta v upon delta t, and yes, I can write this as dv upon dt. A is equal to, it is dv upon dt. Okay, as I can write this, v is equal to dr upon dt. Okay, so yes, A is equal to, you can write limit delta t tends to 0 means delta v upon delta t is equal to dv upon dt. And yes, A is equal to, okay, if you take derivation of velocity with respect to time, yes, what you will get? See, d upon dt. V means, here it is vxi plus vyj. Okay, so derivation of x component of velocity with respect to time, it will give x component of acceleration. Derivative of y component of velocity with respect to time, it will give y component of acceleration. So yes, you can write A is equal to, here it is axi plus ayj. Where what is ax? Yes, ax is equal to, here it is ax is equal to, it is d of vx upon dt, and ay is equal to, here it is d vy upon. Clear about this? So yes, it is equation of acceleration, and with the help of same method you can find its magnitude and direction. Now last point and important, acceleration is in direction of change in velocity. Remember last theory, velocity is in direction of displacement. Here acceleration is in direction of change in velocity. So yes, remember this point, acceleration is in direction of change in velocity. Now in this case, what is change in direction of velocity? See carefully here what you have to do. First of all, take a point. Initial velocity v1 is in this direction. Remember, v1 is in this direction. It is v1. Yes or no? Yes. It is point O. From the same point, draw final velocity v2. It is in this direction. So yes, if you draw v2 in this direction, yes or no? So see, initial velocity is in this direction. Final velocity is in this direction. See, my hand is moving in which direction? Initial velocity in this direction, final velocity in this direction. Means direction changes from this direction. Okay, so what is change in velocity? Yes, change in velocity delta v, it is in this direction. And yes, it is direction of acceleration. Clear about this? So yes, you have to remember this point. Acceleration is in direction of change in velocity. If it is initial velocity, it is final velocity, then in which direction there is change in velocity? See, movement of hand. v1, it is v2, means this direction of change in velocity, and acceleration is in this direction. Clear about this? So yes, it is all about position vector, displacement vector, average velocity, instantaneous velocity, average acceleration, and instantaneous acceleration. Clear about this? Yes. Now in next lecture we will see equations regarding such definitions. Okay.